graph an absolute value function. We're going to be graphing y equals 0.5 times the absolute value of x minus 2. Think of what happens with the absolute value part of this function. The absolute value of a number is never negative, so the smallest it can be is 0. Let's find out when it is 0. If you set the insides of the absolute value, the x minus 2 equal to 0, that occurs where x equals 2. Let's go make a table of values. So here's a table of values I set up. I set x equal to 2 in the top row. That's where my absolute value is 0. I'm going to take a couple steps to the right from there, so go up to 3 and 4, and a couple steps to the left of 2, 1 and 0, and fill in my table of values. Let's see what happens when we plug in our values. At x equals 2, we plug that in, y is 0. We go one step to the right, and we plug in 3, then y is 0.5. So one step to the right, y went up 0.5. We go another step to the right, y goes up another 0.5 to 1. If we start from 2, 0 and go one step to the left, when x is 1, y is 0.5. So we went one step to the left and up 0.5. We go another step to the left, and we're going to go up another 0.5, a linear change in this direction. y2 plus is going to give us some choices. We know we don't want this one, because from 2, 0, the lowest our y ever got, it's going to be linear changes, not some curve. It's not going to be this one, because in both directions from 2, 0, it went up. So we're going to use this other guy, and I'm going to put the end dot at 2, 0, and from that point, as I step to the right, every time I step to the right one, I went up a half. So by the time I went over to 4, I went up to 1. So I had the 0.41. That takes care of this part of it. We need the part that goes to the left one, still goes up 1. So we need another one of these guys, and put the end of it at 2, 0. And we know when we go to the left one, we go up a half, to the left one, another half. So our curve goes through 0, 1. And there you have it, a graph of an absolute value function.